Hey all, happy Friday. I've got a basics for you. I'm going to talk about the basics of inductive sensors. But before I do that, I need to talk about a global problem that everybody knows about. We've got this global chip shortage. And do you know why? Because robots thought they were snacks. Ah? Ah? Okay, that was a bad one. I know they're all bad, but that one was pretty bad. Microchips, chips, robot snacks. Anyways, okay, so I'm going to talk about inductive sensors today and the basics of how does an inductive sensor work. And an inductive sensor, I've got a little tester here, and the tester is going to make a beep when it sees a target. But an inductive sensor, basically there's a coil in the end of the sensor here, and the coil creates a field. It's called an eddy current. And when metal, specifically iron-based metals, steel, enters the sensing range, the sensor turns on. You can see the light turn on, you can hear the beeping. So that's an inductive sensor is looking for metal to enter the field. Now, one of the things you got to know is that when a target enters this way, you can sense it farther away. When it enters from the side, it's got to be a little bit closer. The size of the target matters. So if I just try to detect the point, I more or less have to touch the face of the sensor to get it to turn on. But if I've got this big, wide space, I can actually detect it easier. So an inductive sensor is using that field and the presence of the metal and the amount of metal present in the field is going to decide whether the sensor turns on or off. So I'll go into other inductive topics here over the coming weeks, but for now, that's how an inductive sensor works. It creates an eddy field, and the presence of metal turns the sensor on or off. It's one of the most commonly used sensors in manufacturing automation. So until next time, ask yourself, what will I automate next?